Okay, so this topic on managing files, this actually can be kind of fun. It's, the first one of a bunch of fun things we're going to start doing more and more of. And I'll just get the recording going. Or sorry, the slideshow going here. What goes up? No, I promise I won't sing too much here, but we know what comes next, right? Must come down. So we actually have to look after, yeah, in the real world, most sites eventually need to manage things like files and other kinds of uploads and so on, right? So there's really two parts to this, right? Getting them up and down, okay? File upload, file download. How do we manage that whole aspect? And then the other part of it actually is where are we going to store them once they upload them, right? So there's really two parts to this. And the main choices for storing them, we can actually store them in the file system. Now, anybody who played around with websites from years and years ago or early on as a beginner or a novice HTML coder probably did the same thing. You would create a little slash uploads folder, right? Right in the root of your website or something. And somebody would upload a file, and it was pretty straightforward. The code used to actually just save the file they uploaded into the uploads folder, right? Things like that are pretty common and easily done, right? But we're going to talk a lot about why that's a very bad choice. Okay. Other better choices are we can actually store them, believe it or not, right in our database. Yeah. We don't have to have a separate storage container, so to speak. We can just stick them right in the database itself. And there's advantages and disadvantages to that, which we'll talk about. Or there are actual document servers. There's all kind of like SharePoint itself, for example, is an example of a document server. That's one that I think we're all familiar with, right? So we'll touch on that briefly as well. We're going to focus on using a database. I'm giving away the plot even before we're getting into the meat and the potatoes of it. But first of all, okay, where to store them? Well, as I said, the file system was a common thing done. Okay, it's very easy to code. And you can even just go with an FTP tool into your website and you can see all the files. You can organize them in folders if you want, manage them in all different ways, right? Doing backups and so on and so forth. It's a little faster to get up and going and even performance wise, nothing quicker than just having an object there that you just download when you have a link going directly to it. Ooh, a link going directly to it. That's a very bad thing, right? Uh, Con is very loosely coupled, right? So we don't have any way to kind of maintain integrity. What if you want to delete one, but accidentally it doesn't get deleted or for some reason, right? Or you delete, remove the wrong file, things like that, right? We want nice referential integrity to make sure that, it's kind of like a cascade delete. If you delete a customer and then these files are related to that customer, well, then they should be deleted as well. Does that happen automatically? No, if you take just store the files on the server approach, right? Got to manually delete them along with the records and so on. And you have to give file access permissions, sometimes required on the server, right? It's a major security issue, right? And it's just not a safe practice at all. Fine for a little amateur website, maybe, but certainly not in the professional world, right? Okay, so let's talk about our next main choice in a database. Easily, right, relate to other information. We can do join style queries, actually enforce referential integrity, cascade delete if that's what we want, and so on and so forth, right? All the data is in a single location, okay? When you back up and restore the entire database system, all of these files get backed up and restored and so on as well, right? No special permissions on the web server required, file access permissions and so on and so forth, right? So very easy in that respect. Are there some cons? Sure there are, right? Main one is that you can only access the files through a database connection. Is that really a problem for us? No, I mean, we're working through our database connection all the time. Here's a bigger one. To preview the file, right, you actually have to pull it out of the database and materialize it into an object first, right? So that can be a little bit of a pain, but it's really not that bad. But it does mean we must execute some code in order to download it. We can't just have a link there, but that makes sense. You think about our links, right? We're following a certain approach with our controller slash action, right? Our default routes. They aren't actually anything like links to a file structure on the file server. We don't do that, right? And it's probably best not to be doing that. So, we're okay the fact that we actually have to work through our controllers to get this done. Okay, so the other big aspect is the web server is sitting where? It is in front of the firewall, right? And that's not a safe place to have any important information sitting there. We want it behind the firewall, right? The web server has to be out there or people can't get to it. So whether it's a database server or some sort of a document server, right, it's going to be in behind the firewall. And that is the best way to have it arranged. Okay. Now, that's the second part. Let's get back to the first. How do we actually manage uploading and then downloading these files, right? Well, I don't know if you ever did any much work with web forms. Okay, web form programmers had this nice little file upload control. They would just stick on the web form and bada bing, bada boom, right? No big deal. But it's not that much harder for us. With MVC, it's a little wee bit more work, but we actually have full control over it because we write the code ourselves, right? It just doesn't take very much code. Okay. And we're going to focus on storing files on the database, as I said. And, it's a little bit more complicated, requires a little bit more code, but really it's very, very doable and we're in full control. So what's it going to look like? Well, in our actual view, right, in the HTML of the page itself, we're just going to have, and most important thing we have to add is this, what we see here in the opening form tag. Okay, we want the method post and the enclosure type set to multi-port form data. If for some reason you have everything else in place and you can't seem to upload your files, I can almost guarantee you this is the reason why. You just forgot this little snippet you have to add at the very top of the form itself. Okay, all right, so that's it. You got to add that there. And then we'll have a input type equals what? Type equals file, right? Yeah. Okay, that's an actual input type, and that's all it really takes. By the way, you can have multiple equals multiple as an attribute if you want to allow them to select multiple files, right? This one would be set up to only upload a single file at a time. Okay, so next thing to do on the server side, we have to actually receive it, right? Because we know how our controllers work. We have the view down there in front of the client. They select things, they enter data and all the other inputs. So this file input, they'll just select the file or files that they want to upload. So then it comes into the post action of our controller, right? So it'd be probably for the create, or it could be an edit, right? Either one. So on the server side, what we do is we work with a object here called the iForm file, right? Obviously an interface, but with one of these objects in place, it will accept an uploaded file, right? So we'll just keep in our code examples here. I'll just stick with we're just uploading a single file at a time to keep the code in my PowerPoint simple. When it comes into implementing it, we'll actually work with multiple files. All right, so that's all we do. In our create post action, we just have a iForm file object. I'll probably call it the file, something like that, right? And then that name, by the way, has to match the name we gave the input control on the actual view itself. Okay, so if you, by the way, I note there, you just use a list of them if you do want to allow multiples, and that's what we're going to do in our examples, right? Okay, but we also need to have somewhere to store it, right? That we'll get it up there, and we have it now as an object in code in our controller code that we can work with. But we're going to have somewhere to store it in the database as well, right? So using our code first approach, right, we just basically have to add some properties to a class to set it up and get it ready, okay? We'll need a byte array to hold the actual content of the file. We need a MIME type so that when we pull the file out, we have to provide that. Otherwise, no client can actually properly understand or interpret the content of the file. Okay, MIME type is a standard thing used to indicate the basically the type of file it is. Is it a Word document? Is it a text file, right? Is it an HTML file? Is it an image? And so on and so forth. That's stored in the MIME type. And there's industry standard MIME types used for all the different types of files. Now, the file name, technically, it's not required, right? You can upload the file, save it in your database, and not even worry about the file name. But usually, as a convenience to the user, we'll save the file name of the file they uploaded. We might even let them edit it later on, right? Or we'll just set our own file name. But in any case, we'll probably end up working with the file name. So we could take these three properties and we could just add them. If we wanted to add a file to our patient class, for example, you could just stick these three properties in there, and then you would be able to store a file you upload, for a given patient, right? and that would be fine. That would actually work. It's not the best approach though, right? So we'll talk about better ways to do it, but it gets the job done. All right, a little bit more about this byte array. How this will map, if you're using actual SQL Server database, it will map to a var binary max, which holds a ton of data, right? Now we're using SQLite, so the closest thing we have to var binary max is our good old blob, our binary large object. Sound familiar? That's the one we've used in the past already for our row versions, right? For when we have that byte array for the row version, we use the same thing in SQLite, a blob. Okay, but it doesn't matter too much. That's behind the curtain, right? The the Wizard of Oz is going to look after that for us to a fair degree, and we'll just be able to carry on. Okay, hang on one second. I'm just going to deal with the puppy dog here. So what we're going to do then is look at the kind of code we might put in the controller, assuming we have these three properties, as I said here, in our patient class, right? Well, what I would do in the controller then is, first of all, we check if it says the picture, but think of it as the file, right? It doesn't matter. It's just the uploaded iForm file, right? So, we'll grab the content type property of the iForm file will contain the actual MIME type. So we can put that in a string. We'll get the length of it as well, because it's a good idea to actually make sure they actually have uploaded a real file, right? Something that has some content. So as long as we actually have a MIME type and the file length isn't 0, then it's just a check to make sure we actually do have a file to work with, right? Now this code is written assuming I am going to only allow images, right? And that's kind of a neat thing. We can filter on the MIME type and only allow certain types of files. So maybe your instructions are upload a Word document. Well, you can check, is it a Word document or not? Now, mind you, that's not as easy as it sounds because there's like umpteen different MIME types for different versions of Word, but still you could go through it and find which ones you want to allow, right? Anyway, that's kind of beside the point. Here is where the gut of it actually happens, right? So we prepare a memory stream and we go to our iForm file, in this case on the slide called the picture, and we do a copy to asynchronously, and that copies it into the memory stream, right? And then we just do a .to array for the memory stream, and that returns our byte array, right? And that goes into the actual content object itself. So, if our patient has that image content and then a MIME type and a file name, we can get all the information that way. Okay, let me just move on. I got to get my access to my PowerPoint up here on the screen again. There we go. All right. So as I said here, note it's actually easy to filter by MIME type. Just do a Google search on MIME types. You'll find a big, huge, long list of all the different ones that are out there, right? And you can only allow certain ones to be uploaded. Okay. Now, just a question though, do you see a problem with storing that right in the object with all the other properties? Okay. Think about it. If you've uploaded a huge file, right? Whether it's an image file or even a document of some sort, to something like our patient object, then every time we, go to the index and we, you know, retrieve 100 or 1,000 patient records, right, to show on the index, maybe we were paging them at 100 at a time or something. Well, that's a massive amount of data in that file content, right? So we probably don't want to actually store it right in with the object itself, right, with the main class that it relates to. We would probably want to consider using a one-to-one relationship so that we could do a dot include and include this file that we uploaded if we want to include it with the patient, as in my example. And if we don't, then we don't actually have to pull all that massive amount of the data out of the database, which we probably aren't even going to try to display on the screen because it's actually not in a form that we can display it in many cases, right? So yeah, we don't want to pull that out unless we really do want to include it. So we're going to store it always in a separate object for the most part. Okay? All right, so that's the end of my little slideshow there. But guess what? I have another one. This is one we've used before on POCO relationships, right? Our plain old CLR object relationships. So I'm just going to get that one up here. And we're just going to talk now. We kind of skipped over it before. So we're going to talk about the good old one-to-one relationship and how we're going to actually use that. Okay, so remember here our basic assumption, everybody has a primary key with integer identity and so on, right? Let me just get past that slide. I think I've hidden the other one, so I should jump right to one, oh, no, for some reason I don't. Okay. All right. Let me get back to the slideshow here. Let me start it on this slide. One-to-one. Here we go. All right. So with a one-to-one, there's a couple things to be aware of, and there's actually more than one way to set this up. Okay. It's not as common as our one-to many relationships, and really a many-to-many is just a pair of one-to-many relationships, right? But it's very useful when we want to sort of offload rarely accessed, or in our case, massively large properties out of the principal entity into a dependent entity. Okay. So it's a one-to-one. So they're equals in a sense, but usually one of them is the principal entity and one of them is the dependent entity, right? So what we're going to do is we're going to use this approach to offload mainly that huge amount of data that is the content of the file itself, right? Most one-to-one relationships are technically one to zero or one, okay? Because you might not have a dependent entity related to the principal one, okay? Existence of that is optional, right? But that's okay. It's not going to be a big deal for us going forward. And we're going to actually see that there's more than one way to model a one-to-one using our entity framework core. All right. Think about this example for a minute. An author, okay? We might have the whole biography for the author. So if we store that inside the author, maybe it's a huge amount of data. And every time we just want to get a list of all the authors and show their phone numbers, we go to the database and we're pulling all that out. That wouldn't make sense, really, would it, right? So with our 1 to 0 1, and some of them might not even have a biography yet. So this handles that nicely as well, right? So it's almost the same as a typical one-to-many. The main thing you'll notice, though, is instead of an I collection of the dependent entity, we have a single one stored in the principal class, right? So over here under author, instead of having an I collection of biography objects, we just have public biography, right? Now the dependent entity has its own integer primary key in this case. Okay, so the int author ID is our standard foreign key, right? And that is one way to set up our 1 to 0 or 1. An alternate design might look like this, okay? We get the same relationship with this, but the foreign key in the dependent entity also serves as its primary key, right? So it'll be our biography ID, okay? And we'll have to actually use that uh, annotation here. We say it's the key, which means the primary key, and at the same time, the foreign key for our author object. That's referring to the author object inside of the biography class, right? So those are just two different ways to go about setting up the same 1 to 0 or 1 relationship. In this case, the value of biography ID will match the ID of the author, right? And that's often very useful for us. It will not be an identity. It won't be generated by the database. It will be assigned. So you have to have the author there first, and then you can create the biography related to the author, and it basically inherits, you might say, the primary key of the author also becomes the primary key of the biography, right? Just to show another variation on this overall approach. Uh, we're going to model a farm, right? We have all different kinds of farm animals. We have horses and sheep and so on, right? So how are we going to handle that? Well, we might have common properties to all the animals, okay? Maybe the date that we acquired them and things like that. They might all have a weight and so on. So all of those common properties we could put in the animal class. But some properties that are unique to only, say, horses or only sheep, right? We might use a series of one or a want to be careful of the word, a bunch of different one-to-one relationships to offload those properties that are unique to a certain type of animal, right? So with a horse, okay, we might, have all of those additional properties, things like, I don't know, how many hands high, that's used to measure the height of a horse, right? By a hand, hold up your four fingers, and that is technically supposed to be one hand as a as a measurement of height, okay? supposedly really amounts to about 4 inches, but let's not get too technical with that. Or the furlong speed. How long does it take this horse to run a furlong of distance and things like that? Those properties would only be applicable to a horse. So rather than having them in the animal entity that are sitting there null all the time, right? We can offload them into the horse entity, right? And it's using that same arrangement here. The horse ID will match the animal ID, right? The primary key of the animal, which is just called ID in the animal entity, and it will be the foreign key and the primary key in horse. Exact same thing for sheep. So all the things about sheep, wool color and wool quality and so on, we might store in the sheep entity. Just another example of how we can work with one-to-ones and how useful they can be in our database design. All right, well, we had that whole discussion just so we would have some idea why we're going to take the approach we're actually going to take now. Okay, well, that's an awful lot of talking about theory and so on. So I'm going to break up the recording into a couple stages here, and we're going to get into the actual implementing this now. So I'll stop and start.